All right.
Oh, I did that.
Okay. Exponential functions. So I'm going to cover up some of this. So we're just going to look at number 1 right now. All right. So we will keep 1 and 2 open, but I'm going to focus on number 1. Okay. The directions are graph each function, find the y-intercept, and state the domain and range. Okay, quick reminder, domain is x or y. Good. X, and range is y. Okay, so basically, you don't need a calculator for this because I'm doing all the work with you and for you, okay? So we've done number 1 together. Do you see this graph? This is the graph of an exponential function, okay? Basically, when do we deal with exponential functions? Well, if you look at the graph 2 to the x power, our exponent is not a number, it is a variable, and that's really why this graph looks a little wonky, okay? What I really want you to notice is this graph will never, ever, ever go below the x-axis, okay? So take a second and think about what I just said. When I told you we're dealing with real life situations, doesn't that make sense now why it would never go below? So if we're dealing with material, let's say making plastic boxes. I have no idea why I just said that, but it's the first thing that came to mind. Can you have a negative plastic box? No, that's like maybe in the movie, right. You can have 0, right? Meaning the plant's not working, nobody's working, there's no product. Can you have a negative box? No. So this is basically why the graph is what it is. So now, okay, so let's look at the x values I chose. Now, guys, I'm going to go ahead and tell you, I put this in my calculator, okay? That's where I got these values. So we'll get there, but here is the work itself. You see how I just plugged in the -2 for x and so forth? Okay, go ahead and write all this down. And the y's is obviously the answer. Okay, so you have the points -2 and 1/4 or 0.25. -1 and 0.5. 0 and 1. 1 and 2. 2 squared we know to be 4. And 2 to the 3rd power is 2 to the 8th. So looking at our table, which one is the y-intercept? Right, y'all remember y-intercept, you let x equal 0, okay? So this is the y-intercept here, which is right there, okay? So, find the domain and range. I'm telling you right now, the domain is all real numbers. Okay, write that fancy R sign, which means all real numbers. And just a quick refresher on domain. Okay, it's been a while. All that means is I can use any number on this x-axis. You see how I'm going left and right here? Okay. If you notice, we don't have a whole graph, right? We're only talking about positive y's. So therefore the range, meaning the graph will never go below the x-axis, it will always be greater than 0, okay? I'm giving this to you, okay? This is part of something I'm giving you, all right? Now, you're going to do number 2 by yourself, but I do want you to take a second and copy down I gave you the table. Okay, yes, okay. So you will do this for homework or classwork if we have time right now. Again, look at the domain, all real numbers, right? You can go left or right. And again, this graph, I'm giving this to you, all right? It will never go below here, so we're dealing everything above, so it's greater than 0. What I also want you to notice, this graph will look a little different. Okay, it's going to go the other way. You'll see when you plot. Here are the points. -2, 9, -1, 3, 0, 1. What did I just, again, this is the y-intercept. Very good. And got some decimals here. Estimate, you're going to see there the graph is going to go a certain way. Do the best you can, by all means. What I do want you to notice, what's the pattern on the y's? Are we going up or down? Down. And we're getting closer to what number? 0. We're going to get closer and closer and closer to 0. Okay, you'll see. So if I put in 4, it's going to be a decimal even smaller. Okay. All right, I'm going to hit focus real quick, so I'll give you a second. All right, so I'm going to let you graph that one by yourself. 0.111, 0.037. Oh, look at that goodness, y'all. You see? Woo-hoo. Right? All right, do you hear the word exponent in exponential functions? Remember, function is just a fancy word. We're just graphing. Exponential, our exponent is a variable. That's why it looks a little different. Okay, I'm going to move on to number 3. I'll come back. I'll come back. So here is 3 and 4. All right, again, I have done 3 for you. Aiden, will you turn the lights out for me? So what do we have outside of the parentheses here? What do you notice? We have a 3, and then inside the parentheses 2 to the x. That just changes your y value a little bit. Okay, that's all it does. So domain and range. Guess what the domain is? Again, all real numbers. The range is still greater than 0. And let's look at our values. -3, oh, another fraction. -1, 1.5. 0.3, what's that called, y'all? Y-intercept. There it is right there. And our points are 1, 6, 2, and 12. I estimated 12. If you notice, I went off the graph. Do the best you can. You'll see. It's just going up. All right. As you are writing that down, I want to just discuss what this 3 does. All this 3 does is kind of squeeze the graph in a little more, okay? The y-intercept here is 0.3, meaning this 3 is different than the previous ones where it was at 0.1. And that comes from this number 3, obviously the same 3, okay? It squeezes the graph a little bit. Now, because y'all are doing this in class, I'm going to keep this open when I'm done talking. So if you don't get all of this written down now, that's okay. I need the students on the video because they can pause, okay? So let me go ahead and go to number 4, which will also be done by you, graphs, okay? All you're doing is graphing. I am telling you this is up to. Where do you think the up to comes from? That should look familiar. We're transforming this graph how many times? 2. We're moving it up 2. Remember, plus usually means up, okay? We've done linear transformations. Okay, y'all are looking at me like I got 10 heads. Okay, we've done it before. All right. So when you graph these points, I've given the points to you, the range is different. Look at the range, greater than 2. So you're going to notice at 2, it's going to look a little different, okay? Here are the points. I'll highlight them for you. -3, a hot mess of a decimal. -2, -1, 0, 3. What's that called? That is also the y-intercept. And one more, 1, 5. So you're going to notice this graph is up 2, okay? Domain is all real. We can use any x value. The y's, it will not go below this part right here, okay?
So you start.
Well, you plot the points and you'll see, okay? Please estimate as best you can, all right? Guys, all you're doing is plotting points, okay? All right? We're almost in February. I think we can plot points right now, all right? I'm going to go to the bottom, all right? This is where some patterns come in. All right, here we go. I can just do it this way. Determine whether the set of data shown below displays exponential behavior, okay? This is pretty easy. Write yes or no, explain why or why not. All right, I'm going to write some notes for you will want to write them down. X value and Y value. Look at number 5. Look at the X's. Let's see. Let's compare 5 and, oh, I don't want to give you the answers. Let's see. Times. Okay, let's look at 5 and 7, and you'll do 6 and 8 by yourself. Let's look at the X values in 5 and the X values in 7. What's the pattern in number 5? Well, there may be a pattern, there may not be. So you're going, how many? Somebody just said up 1, right? -3, -2. So here, and what's the pattern in number 7?
Up 3.
Try again. 7, up, no,
4.
there you go, up 4. Okay, do y'all see it? 4, 8, 12, 16, you're going up 4. Everybody got it? -3, -2, -1, 0. Okay, you're dealing with negatives, but you're still going up 1. All right, let's look at the Y's now. Look in the Y's. Okay. And, nope, got you. What's the pattern, though? Yeah, you're right.
Times 2.
Times 2, yes. Okay, yes. So one of these is right, one of these is wrong. Basically, one of these is yes, one of these is no, because the directions say, is this exponential behavior, yes or no? Explain why not. That's where these notes come in, and I'll change to gray. Okay, so for the X value, here's your notes. I'm going to do a little star here and here. The X value will have a pattern of addition. Well, don't both 5 and 7 fit that, right? The pattern's +1 for 5 and the pattern's plus, 4 for 7, okay? Well, the pattern for Y is not addition, but multiplication. Oh.
Five.
So therefore, Ava, is 5 yes or no?
No,
No.
just the Y.
The Y is addition when it needs to be what? Multiplication. Therefore, number 7 is a yes. Okay. Both of those have to work. So you could look at 6 and 8 quickly and tell, it shouldn't take you very long. Okay, I'm going to open this up and show you everything that I've done as best I can when I fix my projector. There you go. Okay. What makes, talking about the bottom real quick, and then I'm going to turn my video off. We're doing exponential functions. There has to be a multiplication somewhere, right? Think of what exponent means. Going back old school, exponent means you're exponentially getting bigger and bigger. Isn't that what multiplication is? Yes. Okay. I am done. Thank you.